All right, I want to walk you through some numbering systems with a specific focus on the binary system and understanding better how it relates to the decimal system, which is a system we're used to. So first of all, let's look at the decimal system. So there's two things you need to know about these numbering systems. Actually, one thing really, but you kind of have to think of it helps to think of it as two pieces of information. One is if we look at the number here that I've just randomly chosen, the 50,932, we have 5 columns. And the first thing you need to know is that each of those columns can hold 10 digits. Hence, it's called the decimal system. And those 10 digits are 0 through 9. All right, so if you start with 0, then you have 10 digits. And 9 is the 10th digit. Yeah, I know that's confusing. That's the first piece of information. The second piece of information is that is really the same thing, but think of it slightly different. So each of these columns, so if we look here, we have a box, and I've put each of the columns in a box. And we know that each of these columns can hold 10 digits. So what is the value? Because we're just repeating numbers, right? Column 1 is going to have the same digits as column 2 and 3 and 4 going from right to left. So how in the world do we make sense of these same numbers just being in a line? Well, each of those columns have a value. And so the second piece of information then is that each value has a base of 10 that grows exponentially. So the first column is 10 to the 0, which you may remember from math. If you raise any number to the 0, you get the value of 1. So the first column is counting how many ones there are. The second column, where it also has a base of 10, so that's our second piece of information. Each column here has 10 as its base, and it's just growing exponentially. So the second column has 1, and if you remember, if you raise any number to the power of 1, it becomes itself. So this column is counting how many 10s we have. So the information that we need to know when we look at a string of Arabic digits in order to know how it's working is, first of all, how many digits can it hold in each column? And that tells us then what the base is. So how each column is going to grow, because everything else is going to stay the same. So these exponents are going to be the same. The first column is going to be 0, starting from the right. The second column will be 1. The third column will be 2. That's not going to change no matter what the system is, and so on and so forth, on up. All right. So there's our two pieces of information. If we know those two pieces of information, which is really kind of one piece of information, it's just they happen to correspond. It's kind of easier to think of them as two pieces of information. Then we can figure out, knowing those two pieces of information, what the value is. So we can do some counting here. Now, again, if you watch my other video, I will talk about how this can be very difficult because we don't really have often most of us don't have a good exercise of separating the value or the total amount that these arbitrary symbols represent and the actual value or amount that we're counting. So let's pause a bit here and let's go back to the previous slide because I actually put here a different kind of numbering system. So the first one I have listed there under the title is tally marks. So this is a numbering system, right? We can think about how that works. It doesn't really work in columns. If we're counting something, let's say, I don't know, grains of sand or grains of rice, why not? We can count those. Then we start with just marking a slash for each thing that we're counting. Let me change the color here so it shows up better against the blue. All right, so the first one we just put, oh, that didn't show up very well. Let's try a different color. Let's try red. Let's see. That's not going to work well for somebody who's colorblind. So I'm going to come over here to the white. All right, so again, we're counting grains of rice. And for each one that we see, we put a tally here. So we start with one tally. That's not a one, that's a tally. We get to the two, we put another one. Let me make these a little bit thicker. We get to the third one, we make another one. There we go. We get to the fourth one and another tally mark, right? So each of those columns, the columns really don't represent anything, as in ours. We're just putting a tally. We get to the fifth one, however, we start another system, which makes it a little bit easy. We are doing another slash there, another bar for the fifth one, but we're going to group it in fives to make it easier to see. And so if we have, we go up to 6, 7, 8, 9, and 10, right? So the columns here don't really come into play. If we want to know how much we're counting, you just count how many slashes there are. And so I could keep on going, right? 11, 12, 13, 14, 15, 16, 17, 18, 19. Well, maybe let's not count all the way to 50,000, but I could, right? So this is a numbering system. This is a way to keep track. Another numbering system that I actually don't have listed here is the Arabic numbering system, right? So one is actually an I, right? And then you get a two, you put another one. You get to the third one, you put a third one there. And then what happens when you get to four? You actually have to, the three columns here again are just like tally marks, but then we're going to start using combination. We're going to start putting where the first column represents kind of a negative and the next column, that's 5. So having it on the left there is 5 minus 1, right? Which is 4. If, however, right, so next is 5 by itself, right? And then if we go to the next number 6, then we're going to put an I after it. And so the I after that represents 5. And then now we're going to add 1. So in this numbering system, the columns do have a significance, but not in the same way that our system with Arabic digits do. Okay, so there's two different numbering systems. You're probably familiar with both of those. We're going to focus on these ones that are using Arabic digits, right? And we start with the decimal. You're used to that. You probably learned this all in first or second grade, right? You learned to count this. Or at least at whatever point you started to learn two-column addition, you learned to carry the one and started learning how to use these columns and how they work. What you probably didn't get told or shown was this part here, right? That what's actually happening isn't just, well, it's exponents, right? So now hopefully you're not in first grade and you're familiar with it. So what's happening here? Let's explain it in more complex terms. The columns here have values. The values of those columns, using the same digits over and over, grow exponentially, as I showed you. So if we want to know, right, we're going to separate. We're not going to assume that just that those numbers that are written there, the 50932, are automatically have the exact amount or value. We have to figure out what amount they actually represent by calculating through how the system works, right? So we know first part of our system is that we're going to have 10 digits in each, and that then is going to tell us how this exponents work, how they grow. So let's start here with the right-hand column. This is going to tell us how many tens to the zeros do we have. So in other words, as we shall before, 10 to the zero is 1. So how many ones do we have? Well, we have 2 ones. So over here, I made it a little bit easy here. Oh, that's big. We'll make that a little bit thinner. So I've written out the math here. So what does that column tell us? Well, you've got 2 of 10 to the zeros, which is the same as saying if you have 2 of something, you have 2 times 10 to the zeros, and 10 to the zero is 1, so you have 2 times 1. So what's represented in that column is 2. And then you go to the third column here, and you do the same thing, but this time it's 3 times 10 to the first, which is 3 times 10. So that's how many tens we have, and so in the second column we have 30. We go to this column here, working right to left. And in this case, we've increased our exponent, right? So it's 9 times 10 to the second, or 9 times 100. So 9/100 is 900, and so on and so forth. In this case, we have 0, 0 times 10 to the third, 0, which is 0 times 1,000, which is, if you multiply anything by 0, is 0. And then finally, we have 5 10,000s, or 5 10 to the fourth. So 5 times 10 to the fourth, write that out as 5 times 10,000, or 5 10,000s, or 50,000s. 5 10,000s is 50,000. So then we're going to add up. This is what we have in each column. And now we're going to add these up. So I can put a little plus sign here, and we add it up. And at the bottom, we get this total. Now, I've done a really bad thing here where I've used the Arabic digit, the decimal system, to define the decimal system. You should never use what you're defining in your definition. But why did I do that? Well, because it's much easier to put that on the slide than to have tally marks for 50,932 items. But that's essentially what it is. So if we have 50,932 grains of rice in the decimal system, instead of doing tally marks, we have these nice little columns. Each of those columns have a value. And because we know that each of them hold a 10, we're going to use 10 as our base. And we're just going to do all this math here. And so here's what you did not know when you were in first or second grade learning to do complex addition, which seemed really hard at that time. And every time that you use numbers, your brain, though you may not have realized it, is doing this whole calculation right here. So your brain is actually probably a lot smarter than you thought it was. You just thought, well, 50,000, there's the numbers, that's what it is. No, actually, your brain is going through this whole calculation and figuring out. Well, theoretically, that's what's happening. At any rate, that's how the numbering system works. Okay, cool. You probably didn't know how smart you were if you've never had this explained to you. Now, we've covered tally systems. I've covered, which is a totally different system. We've covered Roman numerals, which is a totally different system. And then we've covered decimal, or actually we've covered decimal, which is a specific subsystem of another system, which uses Arabic digits and columns. So this is actually easier. What we're going to learn next, we're just going to see binary, is actually easier than switching from tally marks to decimal or from Roman numerals to decimal, because those are totally different systems. They're totally different bases. They don't use columns in the same way. They don't even use the same symbols. We're going to learn and look at how binary works. It uses the same basic systems with columns and Arabic digits. The only thing that's going to change here, the only thing that's going to change is that those two pieces of information, the one here, which is going to be the same as the one here. So in a decimal system, from the word 10, we have 10 digits, again, 0 through 9. And that then tells us what our base is, which then tells us, right, what math we're going to do right here. Those are the only two things that will change, which this and this is the same thing. So it's really just two things. But let me go back. There we go. Take out all the extra stuff. So we're just going to look at the two things here. Two pieces of information that you need to know. All right. So when I switch to the next slide, which is about binary, it's going to look the same. The example number that we're going to work with is going to change. That's all extra. That's random. That's just the example. But the system itself, the only thing that's going to change is those two places, those two pieces of information, right? So see if I'm right. If I'm right, then it should be easy to figure out how to jump from decimal to binary. So you should only see a change in those two things, which you do, right? Okay, so it's not in the exact same spot, but here you go. We've got 2, right? And 2. So what is this telling us? This is the same thing as a decimal. The only thing that's changed is, first of all, how many digits can be held in each column, which tells us then how we're going to do the math to calculate the total. Everything else has stayed the same. So the exponents haven't changed, right? And then everything else is just specific for the example. So that's changed, but that is not about the system. That's about our example. So let's see how this works out with binary. So here's our example number right here. Here's our base of 2. Let's see how this works. Well, the first column, 2 to the 0, is going to tell us, well, anytime you raise an exponent to 0, you're going to get 1. So just like in the decimal system, this first column is telling us how many ones we have. And we'll do this math over here. There's 0 ones. 0 times 2 to the 1 is 0 times 1, which is 0. But now, remember, we're going by 2's. So here, 2 raised to the first power, anytime you raise something to the first power, you're going to get itself. In this case, it's not 10, it's 2. So the second column is going to tell us how many 2's. So we just do the math and we just fill in the numbers. So it is 1. So there is 1, 2 to the first, or there is 1 2's, or 1 times 2, which is 2. In our third column going right to left, now we are, again, this hasn't changed. The only thing that's changed is the base. So here, 2 to the second, if you do the math, that's the same as 2 times 2. 2 times 2 is 4, but this is telling us then how many 4's we have. So 1 times 4, 1 times 4 is 4. And 2 to the third, you multiply again by 2, you're going exponentially. This is how many 8's we have. We have 0 8's, so 0 times 8 is 0. And finally, this is a 5-digit, so in the 5th digit from the left, 2 to the 4th, right? So we start with 0, so our 5th digit is 2 to the 4th. Multiply again by 2, 8 times 2 is 16. And over here, how many 2 to the 4th, or how many 16's do we have? Well, we have 1. 1 times 16 is 16. So now, remove all this so we can see we are simply going to do our addition. So we got the multiplication done. We're going to add it together. And 2 plus 4 plus 16 is 22. So I could actually do the tally marks on that. That would be actually be good. Here, what I'm doing is using a decimal again because you guys are more familiar with it, but I could just as easily do the tally marks, which would look like, get these kind of spread out, aren't I? 22. So this number here and a base of 2 in the binary, where we have 2 values for column, these numbers here change, but the math that we do here does not change. So once you know how many values there are, or in other words, once you know what the base is, you can figure out the rest. And I could substitute these 2 here for any other number, and you could figure out what it is, because the general system of how these Arabic digits combined with columns works does not change. The only thing that changes is the base. Oh, excuse those marks, they should not be showing there. Let's then look at how this works. So once you know how the system works, the rest is really easy. If you want to know what system, if you see a string of Arabic digits and you're like, well, now no longer can I just automatically look at it and know what value we're talking about. Now I have to know what the base is, which of the system it is, of the possible combinations of Arabic digits and columns. So that's the question you have to ask. What base are you using? How do you identify that really quickly? Well, if you're wondering, there's a quick shortcut to figure out which numbering system you're using or what base is being used, and that is to ask, what is the amount represented by the combination of a 1 and a 0, with a 1 in the leftmost column and a 0 in the rightmost column? Well, if it's a binary system, again, sorry about those squiggles. Let's just look at this first here. Maybe bring this in focus. All right, so we're looking at this. If it's a binary system, then the 1 and the 0 has a value of 2 tally marks, or 2. If it's a decimal system, here we go. Now the squiggly marks are making sense for you. If it's a decimal system, then a 1 and a 0 in that combination represents 10. And you could go on. If it's a hexadecimal, hexa here means 6, and decimal we already know means 10. So just like in English, 6 plus 10 is 16. So hexadecimal system, if you have a 1 and a 0 in a hexadecimal system where there are 16 values per column and the base is 16, 1 and 0 is equivalent to 16, which you see there in tally marks. And you could go on and on. You could have, I don't know, a 93 base system. Well, if you have a 93 base system, you'd have to come up with an additional, how many? 84, right? 84 more digits somehow. Um, but you could do that, and the 1 and 0 in that combination there in a 93 base system would be the value of 93. By the way, with a hexadecimal system, what do you do after you run out of Arabic digits, right? 1 through 9, that's only 10. You need 16, so you got to add more 16. Well, what do? Is they just start with the um, Latin alphabet and add 6 more digits, right? So it doesn't really matter. They're all arbitrary, whether you use Arabic digits or Roman digits or tally marks. Well, you could use tally marks, that'd be a little hard. You need something unique. In this case for each additional number. But you could use, I don't know, squigglies or X or question marks, whatever you wanted, as long as they were unique digits to be put into your column. And you could get up to 93 that way if you wanted. It doesn't matter. So that's a simple shortcut to know how to identify what those Arabic digits are actually representing. Is if you can figure out what is the value represented by the 1 and the 0, then you know what system you're in. And it matches 1 and 0 in binary, 2. Binary means 2. 1 and 0 in decimal, 10. Decimal means 10. 1 and 0 in hexadecimal, 16. Hexadecimal means 16. So it's a nice little correspondence there. And so now, with that little shortcut and this explanation, you now understand this joke. You can read it there for a second, because it's hard to know how to read it out loud. But I'll read it out loud this way. There are 1, 0 kinds of people in the world, those who know binary and those who don't.